am Mr. Farid, and now I will help you to overview your lesson today about equilibrium of a rigid body under the effect of coplanar forces meeting at a point. A rigid body is balanced under the effect of two forces only if these two forces are equal in magnitude, opposite in direction, and their line of action are on the same straight line. Like a body on a table. If you have table and you have body, you have balance because the weight, pressure on the table, W, and the reaction of the pressure is R, and they are equal in magnitude, R equal W, and opposite in direction, and the line of action are on the same straight line. If you have F1 and F2 act at a body at point A at a point. So F1 vector plus F2 vector equal 0. So F1 equal negative F2 opposite in direction, and the magnitude of F1 and F2 are equal, and the line of action are on the same straight line, so they are in equilibrium. Transfer the point of action of a force to any point on its line of action. If a rigid body is in equilibrium under the effect of two forces, then we can transfer the point of action for any force to another point on its line of action without an impact on equilibrium of the body. So if you have a point and a point A2 and A1 and A, and another point and the other force B2, B1 and B. If the force acts at point A2, I can transfer the force from A2 to A1 or to A. And here in the opposite force, if the force acts at B2, I can transfer it to B1 or B. Example number 1. If a force of magnitude F is in equilibrium with two perpendicular forces of magnitudes 5 Newton and 12 Newton, find the magnitude of the force F. Here you have magnitude F is in equilibrium with two perpendicular forces. You have two perpendicular forces, 5 Newton and 12 Newton, and alpha equal 90 degrees. So the force F equal the resultant of the two forces equal square root 5 power 2 plus 12 power 2 equal 13 Newton. Example number 2. If the force 7 and 8 and 13 are in equilibrium, find the measure of the angle between the first and the second two forces. The first and the second force. The first force 7 and the second force 8. The angle between them is alpha. 7 and 8. The angle between them is alpha. The resultant of 7 and 8 equal to 13 in magnitude and opposite to the direction of 13. So R equal 13, F1 7, F2 equal 8 Newton, and alpha unknown to you. So R square equal F1 square plus F2 square plus 2F1 F2 cosine alpha. So R 13 power 2 equal 7 power 2 plus 8 power 2 plus 2 times 7 times 8 times cosine alpha. 13 power 2 196 equal 49 plus 64 plus 2 times 7 time 8, 7 times 8, 56 times 2 equal 112 cosine of 49 plus 46 minus 196 divide 112. So 49, 196 minus bracket 49 plus 64 all over 112. So cosine alpha 196 minus 49 plus 64 over 100 equal equal 1 over 2. So cosine alpha equal 1 over 2. So alpha will be equal 60 degree shift cosine. Exercise number 1. The force 10, 16 and F are in equilibrium and acting at a point if the measure of the angle between the first and the second force is 120. Find the magnitude and the direction of F. Here the force 10 and 16 and F Newton are in equilibrium and acting at a point. If the measure of the angle between the first and the second force is 120, so 10 and 16, the included angle is 120 degree, and the force F equal to the resultant of the two forces 10 and 16 and opposite in direction. So the resultant is F. So F equal square root 10 power 2 plus 16 power 2 plus 2 multiply 10 multiply 16 times cosine 120. So it will be, I will calculate it, root 10 square plus 16 square plus 2 times 10 times 16 times cosine 120. The answer will be 14, so F equal 14. So F equal 14 Newton. The direction of F you can get it by tan theta. This is equivalent to F, this is R. Theta, tan theta equal F2 over F2 sine alpha. So 16 sine 120 over F1 10 plus 16 sine 120. So 16 sine 120 over 10 plus 16 cosine 120 equal 4 over 3. 4 root 3 shift 10. So theta 1 equals to 81 degree and 47 minutes 12 seconds. So if make an angle of measure 81 degree, 47 minutes and 12 seconds with the second force.